Hello everyone, welcome to today's topic of discussion AUTOSAR Overview by S2 Technology. Myself Surbhi Hagavne, working as an AUTOSAR engineer with S2 Technology. So I'll be taking you to the topics such as AUTOSAR introduction, necessities of AUTOSAR, characteristics of AUTOSAR, non-AUTOSAR versus AUTOSAR architecture, AUTOSAR consortium, AUTOSAR concepts, and AUTOSAR architecture, which we'll be seeing in more details in upcoming sessions. So let us get started with the AUTOSAR introduction. What AUTOSAR stands for is the Automotive Open System Architecture, which was founded in 2003 by the automotive OEMs and suppliers to avoid redevelopment of similar components. So the major objective of AUTOSAR is to create and establish an open and standardized software architecture for automotive electronic control units. As we move on to the era of electronics, the vehicle complexity is the major concern of OEMs. So there are lots of ECUs and its equivalent functions getting involved, which is the major concern for the OEM. So the OEMs along with the tier 1, tier 2s and tool vendors, they came up with a concept as a AUTOSAR in order to avoid the redevelopment of similar components. Hence, AUTOSAR goals at the scalability wherein one application can be scaled onto the different kinds of ECUs. Transferability, when you want to transfer certain functions from one ECU to other ECU, this is also possible. So it goes at the transferability and collaboration. So since the OEM tier 1, tier 2s, tool vendors and the semiconductor industries have come together and formed a collaboration, so we can say it goes at the collaboration. So characteristics of AUTOSAR architecture: ability to integrate software modules from different sources, possibility to distribute applications across ECUs. Hence, the OEMs can now effectively relocate any function among ECU using RTE, which reduces large efforts when relocating function between ECUs and effort of reusing function. BSW standardization, hardware abstraction. So the reusability of platform component is possible because of standardized components and interfaces of AUTOSAR, and the standardization of exchange formats like ARXML is supported. Let us understand the difference between non-AUTOSAR versus AUTOSAR architecture. In the conventional architecture, software and the hardware were tightly coupled to each other. So if there is any change in the hardware, that particular software also needs to be updated, which was increasing the development time and cost, and also the efficiency and quality were degraded. So the OEMs along with the suppliers, they came up with the AUTOSAR concept, in which so the hardware and the software are independent of each other. So for example, OEM can give the application to develop to some, say S2 technology, and the software, basic software to the Bosch, and they can buy the hardware from the Infineon. So here independently they are developing the software, so the time and cost is also reduced and the efficiency and quality are increased. The AUTOSAR consortium, it was bought up by the 9 core partners, 55 premium partners and the 6 development partners, along with 85 associate members. So the concept of AUTOSAR, so the concept they had designed it on the basis of architecture, methodology and application interfaces. So in architecture, software architecture including a complete basic or environmental software stacks for ECUs, AUTOSAR basic software. Methodology, so the format exchange or the description templates are defined by a BSW stack, or the integration of software, how the integration needs to be done, that is defined by the AUTOSAR concept, so we call it as a methodology. And application interfaces is nothing but all your syntaxes and semantics will be defined specific to the interfaces. So we can say the specification of interfaces of typical automotive applications for different domains in terms of syntax and semantics. Let us understand the AUTOSAR architecture with an example of an assembled computer. So here we have the assembled computer as a hardware. So for example, your CPU and monitor will be from Dell, and mouse and keyboard from HP. So this will consist of the hardware part in the AUTOSAR module. Then we have the OS, which is equivalent to the runtime environment, which is the system software manages computers, hardware and software resources and provides common services for the computer programs. So basically this is nothing but the Windows OS will help us to integrate the applications over it. So then we have the application layer where the user can have multiple applications installed as per its requirements. So here we can conclude like the in the AUTOSAR, the computer resembles to the hardware, the Windows OS, which it represents to the runtime environment, and the applications resembles to the application layer. So here is the AUTOSAR architecture, wherein BSW is the basic software layer, then the RT, which is nothing but acting like OS. Here is the hardware, like microcontroller is nothing but our, as I showed, the assembled computer maybe. And then basic software is the softwares which will be required for executing the actions. The RT layer, which is the communication medium, so that the data can pass from the application to the basic software layer, and from the basic software, from the controller to the basic software, and to the application. And application layer is, so you can have multiple applications which you want to implement on the application layer. So the standardized ECU software architecture is the separation of, so this is the standardized ECU software architecture, which is the separation of a hardware independent application software. So your application software is independent of the microcontroller layer, that is the hardware oriented. So it's hardware oriented basic software, and by means of software abstraction layer. So this two will be communicating through a software layer, software abstraction layer called runtime environment. So to conclude on this slide, we can say AUTOSAR consists of three layers: basic software, RT, and the application layer. So the AUTOSAR architecture is further divided into AUTOSAR layered architecture, wherein BSW is further divided into microcontroller abstraction layer, ECU abstraction layer, services layer, and the complex device drivers. So what basically microcontroller abstraction layer does is it speaks with the controllers. So it has all the drivers implemented in the microcontroller abstraction layer. Then we have the ECU abstraction layer, which interfaces the drivers of the microcontroller abstraction layer. It also contains external drivers. So this ECU abstraction layer, it enables, so one application is not will not be coupled with certain ECUs. So this ECU abstraction layer gives that benefit. Then we have the services layer, where in service it offers the functionality of Operating system functionality, vehicle networking, memory services, diagnostic services, ECU state management or logical and temporal program flow monitoring or cryptographic services and many more. And the complex device drivers is a module which implements non-standardized functionality within the basic software layer. So the functionality, so complex device driver, so the non-standardized functionalities, so like the injection control or the electronic valve controls. So these functionalities can be communicated, can be wrapped up in a wrapping paper, and then it can put into the AUTOSAR layer so that it can communicate through the microcontroller to the directly to the application or from or via RT. And then comes the runtime environment, the RT, which is just a communication modem to communicate between the basic software and the application layer. Then the further AUTOSAR detailed architecture. So this basic software is further divided into multiple system services, memory service, crypto, communication modules, the IO hardware abstraction. So we will see in the upcoming slides how what is the purpose and how is the working of this basic software methodology. So stay tuned and stay connected for our further sessions. Thank you.